Hello everyone, this is Dr. Neelam Singh from ITS College of Pharmacy. So, in this lecture we will discuss the rest of the derived properties of powder particle, that is bulkiness and powder flow properties. So, starts from bulkiness. What is bulkiness? Bulkiness is related to the bulk density. What is the bulk density? Bulk density is density equal to mass upon bulk volume. What is the bulk volume? That is the volume of the actual particle as well as the interparticle space and intraparticle space. Everything has been included in the bulk density. That is the bulk. So, bulkiness is the reciprocal of the bulk density. So, bulkiness is the bulkiness, or you can say the specific bulk volume is the reciprocal of the bulk density. That means, bulkiness equal to 1 by bulk density. So, if the bulkiness is less, then bulk density will be more. It is an important consideration in the packaging of the powder, because we can decide the powder we can decide the container of any powder on the basis of their bulkiness. For example, as you see, I was seen in your day to day life, suppose that if I want to store a 1 gram of NaCl, that is known as a simple salt. If I am going to store 1 gram of NaCl and 1 gram of talcum powder, this is a dusting talcum powder which we are using. So, if I want to store a 1 gram of NaCl and 1 gram of a talc, so one storage container which we will use for the 1 gram of NaCl, that volume of that container will be less as compared for the 1 gram of the talc, because for the storage of the 1 gram of talc you require a much more bigger container as compared for the storage of a 1 gram of NaCl. Because why? Because the bulkiness of talc is much more as compared to the NaCl. So, this a bulkiness or a bulk density is given an idea for to decide the container size. So, the bulk density, for example, the bulk density of calcium carbonate vary from 0.1 to 1.3, and the lightest or bulkiest type require a container about 13 times larger than that needed for the heaviest variety. There are some varieties. The calcium carbonate is existing in two varieties, one is the lighter form and some other one is the bulkier form. So, bulkier form will require a larger container as compared to their heavier form. Flow properties of powder. Now, we have already discussed the density, all type of density, or the bulk density, tap density, true density, the granular density. So, what is the porosity, what is the void volume. Now, all these factors, all these densities and porosity will ultimately affect the flow properties of the powders, and how the flow property will be affected. Powder may be free flowing or cohesive. Cohesive, that means they are sticky in nature. पाउडर की दो ही तरह की फ्लो प्रॉपर्टी हो जाएंगे, या तो फ्रीली फ्लो होंगे या तो क्या होंगे अटक अटक के रुक रुक के. देयर इज अ हिंड्रेंस इन द फ्लो ऑफ पाउडर पार्टिकल्स. दे आर स्टिकी इन नेचर, कोहेसिव इन नेचर. कोहेसिव, दैट मीन्स द फोर्स बिटवीन द सिमिलर पार्टिकल्स इज नोन एज द कोहेसिव force. If you are flowing 1 gram of a powder or 2 gram of a powder from any hopper and they stuck in the path, that means just because of their cohesive force, the force between the same type of the particles is known as the cohesive force. That is eventually just because of the stickiness of the particles. So, powder particle may be free flowing or a cohesive or a sticky. If the powder particles are free flowing, so it's no need to do anything. They are a free flowing powder particle, but if the particles are sticky in nature, they are a cohesive in nature, then you have to increase their flow property. Why you have to increase their flow property? If you will not increase the flow property, if they will not the powder will not have a good flow property, then there might be, or there most probably there will be a chances of the weight variation in the doses form, either in a capsule or a tablet and any other type of a pharmaceutical doses form. That is why we are monitoring the flow properties of the powder. So, many common manufacturing problems are attributed to the powder flow, that is the powder transfer through large equipment such as a hopper. So, uneven powder flow, if the powder flow will be uneven, then excess entrapment air within the powder, which may lead to capping or a lamination. As you will know, the capping and lamination are the defect in the tablets, and increases the dust contamination risk during powder transfer, and ununiformity or a segregation in the blending, which ultimately leads to the weight variation. So, these are the effect of these are the most common manufacturing problem if the powder will not have a good flow property. So, how will you evaluate the powder have a good flow property or a poor flow property? How will you determine? So, there are different methods to determine the powder flow property. One is the Karst compressibility index, second one is the Hausner ratio, and third one is the angle of repose. So, let us discuss one by one. First one is the Karst compressibility index. So, for the determination of powder particle powder particle flow property, the first parameter, which is the Karst compressibility index. For the determination of Karst compressibility index, we have to know the tap density and bulk density of the powder. And how will you determine the tap density and bulk density of the powder? We already discussed in our previous lecture. So, from that calculation, you will get the value of tap density and bulk density. Just put the value of tap and bulk density is the given formula, then you will get the Karst compressibility index. And whatever the value of Karst compressibility index you will get from this equation, we have to just tally that value from this compressibility index, which is already given. This is the Karst compressibility index, which give the relationship between the powder flow property and its percentage compressibility. Suppose that by this formula, by using this formula, we put the value of tap density and the value of pore density divided by tap density, and we will get the percentage Karst compressibility index is a 5%. Okay. Now, I have to identify whether this 5% powder having a 5% compressibility index. So, whether it's a good, will have a good flow property or a poor or a very poor flow property. Then how will you determine? You know, the value of your calculated Karst compressibility index 5%. So, in this table, where the 5% will lie? Here, in this range, 5 to 10. So, the powder have a excellent flow property. जो powder आपके पास है, the powder which you have a excellent flow property, no need to do anything with this powder, you have just proceed further formulation. But suppose that by using this formula, I will get the flow property is 40, Karst compressibility is 40%. So, where will be a 40? The powder is having extremely poor flow property. So, by calculating the Karst compressibility index, we can know that we can have an idea about the flow behavior of the powder particle, either excellent, good, fair, poor, very poor, or extremely poor. So, next method now, Hausner ratio. The second method for the determination of the flow properties, either poor or good, it is the Hausner ratio. The formula for the calculation of Hausner ratio is the tap density and the pore density or the bulk density. How will you determine the tap density and bulk density or a pore density? You already know. So, now Hausner ratio की value, if it will come 1.2 और if the value of Hausner ratio, जैसे आपके Karst compressibility index में एक probability की table थी जहाँ से आप tally करते हो, तो similarly in case of Hausner ratio there is 3 values. अगर Hausner ratio की value आती है less than 1.25, then it will be a good flow. It will be, if it will be greater than 1.5, it have a poor flow, and if between 1.5 to 1.25 to 1.5, then you have to add the gradient to improve the flow property. Now, what are the gradient? We will discuss on the next slide. So, you can determine the flow property by Karst compressibility, second by Hausner ratio, now third angle of repose. There are different methods to determine the angle of repose. Here we are discussing the static funnel method for the determination. How will you determine the angle of repose by static funnel method? See, this is the funnel, and a static funnel, that means you have fixed that funnel or supported that funnel from there from some place. That funnel is not revolving, that is the static funnel. So, what do we have to do? This is the static funnel as you see in the picture. Suppose that this is your funnel and this is the paper. Now, you have to pour the powder from this funnel, and this powder come down and make a heap or a pile of the powder. ऐसा ही होगा ना, जब आप पाउडर को किसी फनल से पास करोगे तो नीचे जाएगा और नीचे जाके क्या एक पाइल या हीप जैसे ढेर बना लेगा पाउडर पार्टिकल्स। अब आपको इसका थीटा निकालना है। कौन सा थीटा? विच इज़ द एंगल ऑफ रिपोज? this angle is known as the angle of repose, that is the tan theta. How will you determine tan theta? H, this is the H, and R, H divided by R equal to this theta. So, for the determination of this theta, you have to know the value of H and R. और ये थीटा कहाँ से बना? जब आप static funnel से when you pass the powder through this funnel, the powder will passes and reaches to the bottom of the on the paper, and here it will make a pile or a heap. Now, what you have to do? Just you have to determine this angle, this tan theta is equal to H upon R. For this, you have to determine the H of the pile, that is the height of the pile, as well as the radius of the pile. Now, how will you determine the radius of the pile? Just you have to just draw the dots around this pile, similar like this, and then just measure the diameter. Since the sphere or the circle which you will draw, that will not be symmetrical in shape, because the pile, the heap of the powder will not be exact perfectly spherical. So, this may be like the circle may be like this. So, for this what you have to do? You have to determine the diameter from the different dimension and just take the average of this diameter and divide it by 2, then you will get the value of R. Then how will you determine the H? Just take a capillary, wet that capillary, and you have to insert that wet capillary from the top of that pile. So, whatever the height of the pile, that much amount of whatever the height of the pile, that portion of that wet capillary, in that portion of the wet capillary tube, there will be powder will be sticked. Suppose that this is the wet capillary you are inserting here. So, what and suppose that this is the height of the pile. So, in this area, the since this capillary is wet, so the powder particle will stick on this capillary. Just remove this capillary and measure this length from the scale. So, then in this way you will get the value of H. Now, we will get the H and R. So, if tan theta is equal to H upon R, then theta is equal to tan inverse H upon R. In this way you will get the value of theta, and now this tally the value of theta in the compressive in the angle of repose flowability scale. Suppose that from here I will get the value of theta is 38. Check. Now, where 38 will lie? Here. So, the flow property of a powder is fair. So, if the powder flow property is excellent, good or fair, do not need to do anything. But if there is passable and a poor or a very poor or very poor category, you have to do some you have to add something, or you have to do some measures to achieve the flow property towards fair, good or excellent. So, in this case, in our previous example, the flow property of the particle is fair, so no need to do anything. So, there are 3 methods to determine powder flow property, either Kar's compressibility index, Hausner ratio or angle of repose. You can determine the this flow property by any one of the method, and whatever the value will get in the Kar's compressibility index, so you have to tally that value with the compressibility scale. Here then Hausner, similarly for the Hausner ratio as well as for the angle of repose. So, now if the flow property which we obtained from either by using either this method, if the flow property is good, fair or excellent, either excellent, good or fair, then no need to do anything, everything is good and fine, we will proceed for the next step. But if it is poor, passable, very poor, very very poor, तो हमें क्या करना पड़ेगा, what we should do to improve its flow property. ऐसा नहीं हो सकता कि very very poor को हम कुछ ऐसा करके excellent कर दें, no. पर क्या कर सकते हैं हम इसको, इट कैन बी अप टू राइट अ पॉसिबल टू फेयर रेंज, सो दैट एटलीस्ट द फ्लो प्रॉपर्टीज somehow or some extent it will be increased. So for doing this, what are the different measures, how will you improve the flow properties of powder? You can improve the flow property by particle size, by monitoring the particle size and its distribution, its shape and texture, surface forces, that means the drying and dehumidification of the powder particles, and flow activators. So there are 4 methods by which you can determine, by which you can improve the flow property, the powder, which if the powder particles having a very poor flow property. But among these 4, the flow activator is the best way or the result oriented way to improve the flow properties of the powder. They all are the accelerating factor to increase the flowability, but the flow activator, the chemicals, the material which are that are known as, basically these flow activators are known as the glidant, which are used to increase the flow properties of the powder. So let us discuss one by one. Factors affecting flow properties of powder. First factor, what is that factor? Alteration of particle size and particle size distribution. As we know, if the particle is very big, so there the flow property will not be good. If the particle is very tiny, very small, then ultimately flow property will not, the flow property which will operate will not be good. And if the particle having the optimum size, then in that case the particle will have a good or even excellent flow property. So if the particle is very small, suppose that there is 3 types of particles, big, small and small. When we drop this particle from the certain height, what will happen? क्या लगता है आपको, ये पार्टिकल आराम से नीचे आ जाएगा? अब इसे आप किसी हाइट से नीचे ड्रॉप कर रहे हो, एक इस पार्टिकल को ड्रॉप कर रहे हो, एक इस पार्टिकल को ड्रॉप कर रहे हो, व्हाट डू यू थिंक, विच पार्टिकल मूव्स इजीली, कम डाउन इजीली? जो इस बहुत बड़ा पार्टिकल है ना, वो इजीली ग्लाइड होकर नीचे नहीं आएगा. व्हेन अगर आप इसको किसी का हाइट से ड्रॉपिंग दिस पार्टिकल फ्रॉम द सर्टेन हाइट, इट विल नॉट कम like a smooth way. How it will move? It will move like just like like a stumbling block. It will stumble. It will not move freely. And similarly, in case of a very small powder particle, where it will entangle, we don't know. कहाँ ये रास्ते में entangle हो जाएगा, फंस जाएगा, हमें नहीं पता. But if the particle have a optimum size range, so it will glide easily and reaches to the bottom. So for the excellent or good flow property, we require optimum size range. हमें बहुत छोटा भी नहीं चाहिए, हमें बहुत बड़ा भी नहीं चाहिए, हमें क्या चाहिए? Optimum size range का. Optimum size range है तो excellent flow property होगी ही होगी. You don't not required to do anything. बट अगर बहुत छोटा है तो हमें इसे ऑप्टिमम तक लाना है, बहुत बड़ा है तब भी हमें उसे ऑप्टिमम तक लाना है. उसे लाने के लिए क्या करना होगा? बहुत अगर स्मॉल पार्टिकल है तो आप उसका ग्रैनुलेशन कर दो. by granulating this powder particle you will get this particle size. बहुत बड़ा है तो उसको माइक्रोनाइज कर दो और माइक्रोनाइजेशन के थ्रू यू विल गेट द ऑप्टिमम साइज. So to achieve the optimum particle size range, for the smaller particle you have to go for the granulation, for the larger particle you have to go for the micronization. क्योंकि अगर बहुत बड़ा अगर पार्टिकल होगा तो भी उसकी फ्लो प्रॉपर्टी अच्छी नहीं होगी और बहुत छोटा होगा तब भी अच्छी नहीं होगी, क्योंकि छोटा कहाँ इंटेंगल हो जाएगा यू डोंट नो, और बड़ा तो जस्ट बिहेव लाइक अ स्टम्बलिंग ब्लॉक. So in that case we have to maintain the optimum particle size range, either by micronization or by the granulation. Altering the particle shape and texture of the particle. As we know, if the spherical particle, there will be a good flow property. If the irregular particle, the particle flow property will not be good. Why? See, the spherical particle, friction free, कोई फ्रिक्शन ही नहीं है, एक ये पार्टिकल है दूसरा ये पार्टिकल आराम से एक दूसरे के ऊपर ग्लाइड होते हुए मूव कर जाएंगे क्योंकि वहाँ फ्रिक्शन नहीं है। लेकिन यही अगर इरेगुलर पार्टिकल हुआ तो देयर विल बी अ फ्रिक्शन, और अगर फ्रिक्शन होगा तो अल्टीमेटली जो इसकी फ्लो प्रॉपर्टी होगी वो डिक्रीज होगी। एज यू सी इन द रोड, व्हेन वी आर मूविंग राइडिंग अ बाइक इन द रोड एंड द रोड इज वेट ड्यूरिंग अ रेनी सीजन, so what will be, there are much more chances for the skidding of that bike. Why? Because there is a no friction. अगर फ्रिक्शन नहीं होगा तो आराम से आसानी से पाउडर मूव कर जाएगा। लेकिन अगर एसिमेट्रिक, हमें पता है हमारे पाउडर पार्टिकल्स इरेगुलर शेप के भी हैं, एसिमेट्रिक भी हैं, तो उनमें फ्रिक्शन है जिसकी वजह से फ्लो प्रॉपर्टी अच्छी नहीं होती। सो पार्टिकल शेप एंड पार्टिकल टेक्सचर इज ऑल्सो प्लेइंग द इम्पॉर्टेंट रोल इन द केस ऑफ द पाउडर फ्लो प्रॉपर्टीज। So generally more spherical particles have better flow properties than more irregular or asymmetric particles. Spherical particles are obtained by spray drying or by temperature cycling crystallization. That means we can convert this irregular particles to the spherical by using the spray drying or the cycling crystallization process. Particle texture. As we know, if the particles texture is rough, irregular, there will be a much more cohesive force and powder flow property will be poor. Third one, alteration of the surface forces. This surface forces is regarding to the drying of the particles. So drying of the particle will reduce the cohesiveness and improve the flow property. अगर wet है पाउडर, गीला है, as you see in day to day life, अगर कोई चीज़ गीली है, पाउडर गीला है, तो you can easily pour them. But अगर पाउडर dry है तो it will become a free flowing powder. So dehumidification or drying is the one way to improve the flow property. हाइग्रोस्कोपिक पाउडर जहाँ भी रखोगे एम्बिएंट एटमॉस्फेयर के ह्यूमिडिटी को एब्जॉर्ब कर लेंगे, तो वो खुद ही इतने हाइग्रोस्कोपिक हैं, तो उनकी फ्लो प्रॉपर्टी अच्छी कैसे होगी? टू मेंटेन देयर फ्लो प्रॉपर्टी यू हैव टू स्टोर सच टाइप ऑफ अ पाउडर पार्टिकल इन द क्लोज्ड कंटेनर दैट शुड बी मेंटेन द शुड बी कीप अवे फ्रॉम द दैट दिस एम्बिएंट एटमॉस्फेयर सो दैट their hygroscopic nature can be controlled. Third one is the formulation additive. As I already told you, there are several ways to improve the flow properties of the powder, but the formulation additive or a flow activator or so called glidant is a much more effective way to increase the flowability or flow. Others are the assisting way to improve the flow property, but the best way or the most result oriented way to increase the flow property is your flow activator, that are also known as the glidant. Glidant का मतलब क्या है? जो चीज़ ग्लाइड करवाए, जो चीज़ एक दूसरे को ग्लाइड करवाएगी, स्किड करवाएगी, यानी फ्रिक्शन कम होगा तो अल्टीमेटली फ्लो प्रॉपर्टी इंक्रीज होगी. So these flow activators are also known as the glidant, and some simple example of glidant as you see in your day-to-day life. When you are playing a carom and when you are just during this, if your dice or it's not moving properly, so what you are doing, just sprinkle the powder, sprinkle the talcum powder. So what the talcum powder is doing, the talcum powder is act as the glidant. So it will improve the flow property. It will similarly in a case of powder particles and pharmaceutical powder particles, the glidant will improve the flow property of the powder particles. How they will improve the flow property? They will make a uniform layer around the particles and give the particle to a smooth texture and a smooth spherical texture, so that there is a less friction between the particle, less cohesive force and much more flowability of the particle. And the glidant, what was the simple glidant is talc which you are using. This is you're playing your carom or on some other games. So for the easy gliding of your dice. So these are this talcum is act as that is talc is used as the flow activator, magnesium stearate is used as a flow activator, maize starch is used as the फ्लो एक्टिवेटर. एंड मैक्सिमम अमाउंट ऑफ, ऐसा नहीं है कि आपको फ्लो बिहेवियर बढ़ाना है तो ठीक है 1 ग्राम पाउडर है तो उसमें 1 ग्राम ही फ्लो एक्टिवेटर डाल दो, 1 ग्राम ही मैग्नीशियम स्टेरेट डाल दो, इट बिकम अ 2 ग्राम एंड द flow property will be excellent. It's not, it will not be like this, because you can't add this excipient to up to a much more extent. आप बहुत ज़्यादा इन्हें use नहीं कर सकते, after that it become create a toxicity. So there be a maximum permissible limit of all the GRAS standard excipient generally regarded as safe. Whatever the excipient you are using the pharmaceutical, these are the GRAS standard, GRAS. GRAS is known as generally regarded as safe. Only GRAS standard polymer you can, GRAS standard excipient you can use for the formulation process, and there is some permissible limit of that excipient, how much, up to what extent you can use that excipient. So here magnesium stearate is also an excipient to improve the flow property of the powder, and maximum permissible limit of this excipient is 1% or 1% or less. Now application of flow property. Why we are studying flow property? कुछ is there somehow related to our dosage form, या ऐसे ही बढ़ रहे हैं flow property? We are studying flow property because फ्लो प्रॉपर्टी कहाँ पे रिक्वायरमेंट है, जब आप पाउडर को एक जगह से दूसरी जगह पास करो, एंड एवरी मैन्युफैक्चरिंग प्रोसेस फ्रॉम द प्रोसेसिंग फ्रॉम द रॉ मटेरियल टू द मैन्युफैक्चरिंग साइड, एवरीवेयर फ्रॉम द इवन इन द पैक, इन द फिलिंग ऑफ अ कैप्सूल और पंचिंग ऑफ द टैबलेट, everywhere there is a conveyor belt through which you have to flow the this powders. If there is not a good flow property of the powder, they have a sticky in nature, they have a much more cohesive property, so it will not flow properly. और अगर flow properly नहीं होगा तो ultimately effect क्या आएगा, there is chipping, lamination, capping, whatever the defect obtained in case of tablets, or a weight variation in case of a capsule filling. So to avoid all these defects in the form, in the dosage form, what we should monitor? We should monitor the flow properties of the powder, and flow property is the derived properties of powder. So this is all about further this lecture. In this we have studied the derived properties of the powder, and what are the derived properties of the powder? We studied the bulkiness, which is the reciprocal of the bulk density. Then we studied the flow properties of the powder. How will you determine the flow property? There are three methods: Kar's compressibility index, Haussner ratio, and angle of repose. And whatever the value we will obtain from these methods, we will just tell you the value in their respective compressibility, respective flowability charts. Now factor of अच्छी flow property है, no need to do anything, it's well and good. पर अगर poor आई है, very pure है, then what we have to do? We have to just improve the flow property by adding some activator, flow activator, or some modification of the particle size. So these are different ways to improve the flow property: particle size, distribution, particle shape, texture, surface forces, and flow activator. And the most effective way to increase the flow property is the addition of the flow activator, and maximum permissible concentration of the any flow activator is the 1% or less. So thank you for the today's lecture. Thank you.